Hey everyone, how are y'all doing? Welcome back to another video. In today's video, we're going to go through some secure coding practices. We're going to demonstrate the secure version and the insecure version of the code, and we will learn how to write safer functions, methods, and stuff that go into software. Now, in today's video, I'm going to go through three secure coding practices. And if you guys want to see more of them, please let me know down below and I will make another video. So let's get into it. Now, what is secure coding? Secure coding is the practice of writing software that can withstand malicious attacks. It means thinking ahead, sanitizing input, avoiding unsafe functions, and validating data. Now, in front of you is the OWASP website. The OWASP, or aka the Open Worldwide Application Security Project, it maintains a list of the most common and dangerous software vulnerabilities. You might have heard, as I did on the previous videos, about SQL injection, and today we're gonna go through buffer overflows and cross-site scripting, or XSS, and even more. So today I'll show you two versions of each example, the insecure version and the secure one. Now on this page, as you can see here, secure coding practice quick reference guide, you have input validation, output encoding, authentication and password management, session management, etc. Database security and everything, right? So you go here and you select this subsection and you see if you have managed to do or to follow as many of them as possible into your code. And now let's get into buffer overflows. Buffer overflow. Now here we have an array of 8 bytes, and so an array is basically a buffer, right? So we have this buffer of 8 bytes. Now if we were to enter characters here, right, A, B, C, D, E, right, we have entered these 8 characters. Now what happens if we enter more characters, right? If there is no a bound restriction on our array or buffer, then the new characters will be added, but this will result in a buffer overflow because these new characters now aren't inside the array anymore. They're basically assigned to adjacent data next to this buffer, right? And that could be like important data. So we don't know what we are overriding. Basically, everything that's outside this buffer, right? It overrides whatever's next to declared next to this array. Now, how can we prevent this? There is this thing called runtime bounds checking. The pros of this are that buffer overflow cannot happen if we adapt this, and the cons are that there will be some performance cost. Now, what does this runtime bounds checking do? Runtime bounds checking looks at the size of this array. So when I enter a character, this runs and it checks, okay, so the space is not 8 anymore, but it's 7. When I enter another character, this runs and it says, okay, the space for this array is 6, not 7 anymore. And so on for each and every single one of them. Now, when it goes here, the space is 0. There is no more space, right, to enter anything else into this array. So if we try to enter something else, an error will show up and the program will stop executing. Now, these two programming languages, Python and Java, they have adopted this runtime bounds checking by default, while C and C++ have not. C and C++ are used more to, allow you to dynamically manage memory, while Python and Java do it by themselves for you. You don't have to worry about memory. And now I will show the code that I have prepared to demonstrate the insecure and the secure version. But first, we will get into the insecure version. Now, here we have our code. I have two, I guess, simple programs, and I will run both of them. They are both insecure, but first I will run this. So what do we have here? We have an input array name. We have an array named input, which is of type character, and it can hold up to 10 characters or 10 bytes. Then we have a printf statement, which will print this thing here into the command prompt. Then whatever I entered is going to be retrieved through this function. And this is very unsafe. This is where the vulnerability lies in our code. Because this gets function is vulnerable. It takes everything that the user inputs. It has no restrictions. And finally, this is the printf function that just prints out what I entered. Now, I will run this and I will show you three possible scenarios that can happen. Now, let's enter 10 characters. You see, nothing happened. Process returned successfully. When it's 0, it's successfully. As you can see here, enter something. I entered something, we got it, and then we printed it. Now, what happens when we enter 12 or 13 characters? Now, for this scenario, there are two possible things that can happen. 13. Now, the two possible case scenarios that can happen are: the first one is undefined behavior, meaning that it will finish the program successfully, right? It will look like it's finished successfully because like every single piece of code is run, it's correct. However, this is a bad thing because it can cause vulnerabilities in our system. It can corrupt important data, but we won't see it because we think, okay, because it returns 0, everything has gone fine. But no, everything happens in the background. You don't see it. So if I, oh yeah, and also the second case scenario is basically an error showing up that, or the program not even being able to process this because we have somehow managed to corrupt data. So let's give this a try. You see, process returns 0, meaning that this was returned and the entire function was run successfully. But in the background, we don't know what has happened with memory, right? Now, I will add even more letters and we will see what happens when you add a lot of letters. You see, it says you entered, and as you can see, process returned this here, meaning that we have done something to the memory, right? That's adjacent. This is basically buffer overflow, and I will show you in this next piece of code why it is such an issue. Let me close this and let me comment out this function. Now, let's uncomment this function here. So what does this function do? We have a array named password, which is it is of type character, and it can hold up to 16 characters or bytes. And we have this password check integer variable. Now we print what's the secret password, and then we get that password. And then we perform this function here, which is named string compare. And what it compares is the password that we enter, right? The password that the function will get from us, and this password that I have assigned there. Now, if if the passwords, so basically if I enter overflow and it is identical to this one here, then this string compare is going to return 0. And if it's 0, then we are going to print this correct password and we are going to make the password check equal to 1. If it returns anything other than 0, meaning that the passwords are not equal, then it will print out this wrong password, try again. Now, if we print the correct, if we input the correct password, this password check variable is assigned this new value, which is 1. Now, if the password check is not equal to 0, meaning that it's 1 or something else, right? This is the important part, something else. Then we perform this system start PowerShell. Now let's run this, and the first scenario would be me entering uh, the right password. So let me enter overflow, and as you can see, we have correct password. Now you might ask, what happened? Why did this PowerShell prompt appear? Now let me close this, and as you can see here, correct password, right? So I entered what's the secret password? I entered overflow here. I got the password overflow, and then it was compared here. Since it's the same, it returns 0. And 0 is not equal to 0, this is a false statement, meaning that it does not execute this if statement, what's inside the if statement, but it goes to the else statement and it executes this correct password, and then the password check is equal to 1. And then it goes down here and it checks, is password check anything other than 0? Yes, it is, it's 1 now. And then it will run this start PowerShell. That's why PowerShell appeared here. Now let me close this. The second case would be me entering. I will try to enter more than 16 characters, but I'm pretty sure that I will need to enter even more if I'm looking to overflow this. So I will enter even more than 16 characters. Now, why did this PowerShell command prompt appear? I didn't enter the right password, and the pass check variable is not equal to 1 because I didn't enter the right password. So what happened? As you can see here, it says wrong password, try again. Now, what happened? We got this was displayed to us. We entered that long password which was longer than 16 characters or bytes, and anything else after 16, right? It overrode whatever was next to this uh, uh, character array. And what is the next thing that comes after this character array? Is this here. Basically, those other characters that we entered, they overrode, they corrupted the value here. Now, we don't know what the value of this variable is now. The only thing we know is that it printed this, right? Because whatever I entered is not equal to the password. They are not the same, right? So this string compare returns a value that's not equal to 0, because if they are equal, then it will return 0. Now, if it returns something else other than 0, that means that this if statement is true, and it's going to print this. Wrong password, try again. Now, we didn't set the password check value equal to 1, right? Well, now the password check value, since we added more letters to the password array, now the password check value is basically corrupted, you can say, or it has a new value which we don't know. It's basically this new value comes from those other letters that spill out from this buffer. So since we have if password check is not equal to 0, and that is correct because it is something, the value was changed, but we don't know what it is. The system, we run this command which opens PowerShell. Now I will do this one more with a link. Now let me run this again. Let me enter a long string. Yep, so it's the same thing. We entered a lot of characters which this array could not keep all of them inside it. So whatever was extra basically fell into this here. And yeah, that was basically how buffer overflow works in this kind of code, right? This insecure version. I will show you the secure version now, and it's quite easy. The gets function doesn't check how much data you input. You can overflow the buffer and override the memory, including the return address. That's how many exploits start. Now I will show you the safe version. So here is the secure version. The only change that I did to this entire code is this here. It was before it was gets and now it's called fgets. This is another function. Now what does this function do? So this function, it limits the number of characters, preventing an overflow. So this is the password array. This gets the size of the password, and this is just whatever. It is a predefined library from C++. So if I were to run this, what would happen if I were to enter a lot more than 16 characters? Nothing. This is wrong password, and if I were to remove this with this and run the program again, if I were to remove this function here and return it back to how it was, so gets and then just password, right? And if I were to enter this same length, then a buffer overflow would be performed. And yeah, this was basically the secure versus insecure version of a buffer overflow. Now I will get into SQL injection. Now, web apps. So SQL injection is still one of the most common and dangerous attacks. The SQL injection here would be in this line, which I had commented out. I have done two videos where on the first one I explained how to perform a SQL injection attack, and on the second one I have shown how to protect from SQL injection attacks. Now, this is where the vulnerability lies, because this username here, it's basically retrieved from the request that comes from the login form, right? So if the attacker, if they were to enter, let's say, let me see, okay, we have a root. So if the attacker were to enter root, or right, if they were to enter this and they were to send it to the server, this here would basically be this. It would be a code, not data. So basically, this code, or rather this query, would run this entire thing plus this thing here that the attacker entered, right? And this will this will result into the query returning the user even though the attacker didn't enter the right password. Now, how do we protect against this kind of attack? Well, we have input validation, which is done here, and then you have an if statement that checks. And the second and most wanted way of defending is parameterized queries, where we basically pass the username and password as data, not commands. Even though the attacker might enter this will be treated as data or as a string, and in the database we will look for this exact user which doesn't exist. So yeah, this is basically how you define parameterized queries. So you basically enter placeholders, and then here you define them, which is the username and password. And now finally, so I explained the secure versus insecure versions of SQL, and now I will explain the secure and insecure versions of cross-site scripting. Cross-site scripting. This happens when an attacker injects malicious JavaScript into the page. Now, this is the entire web page. This is where we will enter our input or the JavaScript code. And this is the insecure version. So what happens here? We are grabbing the value. Whatever we enter in the input, we are grabbing it. And this line here is the issue. Because this line here directly injects the user input into the page using inner HTML. Now, why is this dangerous? Because if we were to input something like this, basically a dangerous code, it becomes live HTML and JavaScript. So basically, the alert command here, uh, is executed immediately. It could run arbitrary code, not just hello, right? So any user input that includes malicious tags, for example, I can show you one that's considered malicious, and as you can see here, I'm gonna be running this here because it works. I can show you what happens. I cannot run this, although this is the malicious script that I'm talking about, because Google by default stops some tags, known tags like script, from running. And basically, so yeah, so any user input that includes malicious tags or scripts will be interpreted and executed, not just displayed. Now, if I were to run this insecurely, you will see that JavaScript and HTML work together and we got this. Now, the secure version. In the secure version, we get the user input. These two lines here are basically grabbing the output and then cleaning it. So basically now the first time that I'm running it, these two do nothing. But if I'm going to change the input in a text box and then rerun this again without closing the entire web page, then these two will start working. Anyway, now we have, in the secure version, we have these two new lines here, the save node and this append child. What does the create text node do? So we convert the input into a plain text node, and then this basically means that the HTML tags, the these HTML tags, they will basically become visible characters. They won't be like elements. And this last part here, basically we are adding the text to the page. And even if the user is to enter this, right, which I will show you, even if they were to enter this, it won't execute because it's just text, it's not HTML. So let me render securely. As you can see, we just got this, nothing happened from our web page. Now I can also run this to show you that nothing happens. You see, it just changed, it did not execute. But if we render securely, this space says hello, basically displaying this. And you know, cross-site scripting can be used for various things like stealing cookies and everything. So yeah, this is what I had to show for cross-site scripting. Now to wrap things up. So we talked about secure coding best practices, right? So what can you do to make your code more secure? So something could be validating input, so basically never trusting user input, sanitizing the output, especially in web apps, using parameterized queries, avoiding unsafe functions, following the principle of the least privilege, keep dependencies up to date, use secure libraries and framework, and use secure tools. And I guess one more final suggestion that I can give is, if you're not sure about something, I don't know, a piece of code, a function, a method, something like a library, right? Just look online for it, and maybe like it will, things will pop up saying that this is a very common vulnerability and there are things that you can do to prevent this, right? Which could save you. And yeah, this is all I had in mind for this video. Thank you so much for watching my videos. I really appreciate you guys, and I will catch you on the next one.